Okay, this revision class is mainly to focus problems only. Okay, I don't want to go theoretical side of the chapter. Clear? Because 50% of this chapter comes under problems only. We are having topics reflection of light means mirrors. In the mirrors, we are having the problems. Both concave mirror, convex mirror problems we are having. And after that, we are having refractive index problems. So what we are having after that? Refractive index problems. After that, we are having lens problems. Yes. After that, we are having the power of the lens or combination of the lens problems. Clear that thing? These all categories we will touch today. Understand? And whatever the required things are there, those all we will keep it and we will do it. Understood? Before that, first what I said, we are having the mirror. Yes, right? Which mirror? Curved mirrors. Which are the curved mirrors we are having? Concave and convex. For both the mirror, whatever the mirror it is, it has the formula. What is the formula we are having? Mirror formula, tell me. Mirror formula is, what is the mirror formula we are having? 1 by V plus 1 by U is equal to 1 by F. You know the formula. Good. At the same time, you know what is what very clearly. Okay, what are the things you need to be very clear means what is F? What is F here? Focal length of whatever the mirror it is. If it is concave mirror, what is the focal length? Nature means focal length will become sometimes positive, sometimes negative. So, what is the concave mirror focal length nature? Is it positive nature or negative nature? Keep in mind for concave it is negative. Clear that thing now? For concave, what is that condition? Negative. If it is convex mirror, the focal length will be positive. For example, in the question, a concave focal length, a concave mirror of focal length 15 is used. What you will tell? Concave mirror of focal length 15 is used in that problem. So you will write focal length f is equal to how much? 15 you will put, but be very clear which mirror he mentioned. He mentioned it as like a concave mirror, right? So it is not just 15, minus 15. You might have mentioned centimeters or something. Clear? If suppose he given like this, convex mirror of radius of curvature 30 centimeter. Sir, he given what he has given, see, radius of curvature. That means R he given. What is the R value? 30 centimeter, but I need the focal length for solving the problem. So how do I write that focal length means? Sir, we have one relation, f focal length is equal to radius of curvature divided by 2, half of the radius of curvature, which means how much it will become? 30 divided by 2, which is 50. Now look into the mirror. Which mirror it is? Convex mirror. For convex mirror, f is positive or negative? Positive. Okay, finalize. F is equal to 50. And we will use this value in the problem. Is that clear? So you should not get any confusion in the F. Is that clear? Should not get any confusion in the F. Clear? Now The next person in the formula is u. So the name of u is object distance. What is the name of u? Object distance. What does it mean, sir? Object distance means distance from object to the mirror or to the pole, he will tell. Clear that thing now? Sometimes he will tell it as pole, sometimes mirror itself he will tell. So whatever he said, from the object. Clear that thing now? See, object distance I said, right? Yes or no? It is the distance from the object to the mirror. Okay, clear that thing now? And note one strong point, that you always negative. You always negative. Why? Because we fixed one condition. Why? Object is always placed on left side of the mirror. Object is placed on left side of the mirror. Clear that thing now? And one point is there. It is very important note. What is that note means? There are, while taking the direction, positive direction or negative direction, if these are rays, incident rays, which are coming, if you are measuring the length in the direction of incident rays, the lengths measured in the direction of incident rays are taken as positive, or taken as positive. Or another point is, the lengths measured opposite to the direction of the incident rays are taken as negative. This point you have to be very clear. Understand what is the point? Tell me. If the direction, whatever you are taking, or the length in the direction of incident rays, if you take, that is a positive direction. If the lengths are measuring opposite to the direction of the, incident rays, that will be treated as negative. Remember, always we have to measure the distances from pole. For example, observe, pole is here. Okay, if object is this side, I will measure in this way. Clear? If object is this side, I will measure in this way. Understood that thing now? But observe one thing, when object is here, incident rays are going in this way only, right? All the time. This is the pole, right? You said here, from the pole, the direction you have to measure like this. Incident rays are coming like this, these are going in this way. They both are in opposite direction. They both are in opposite direction. That's why u is always negative. U is always negative. Always negative. Is that clear? Whatever the mirror, concave mirror, convex mirror, u is always negative. Is that clear, that point? Next, the person V. V, what is the name of V, sir? Image distance. What is the V? Image distance. V means image distance. Sir, as I said earlier, distance from the image to the, see, distance from the image to the pole or mirror. Sometimes instead of image, we will use one special word called screen, because we have to place the image on screen only all the time. That's why we'll use one word called screen. Distance from screen to the pole or mirror is also called as image distance. Understand that thing, no? The distance from screen to the mirror is also image distance. And keep one point in mind. We know convex mirror, convex mirror, the image is formed on which side all the time? The image, whatever is going to form, is a virtual image. Clear that thing now? Since it is a virtual image, the V is positive all the time. Since it is a virtual image, V is positive all the time. Keep in mind, for convex mirror, V is always positive. For example, you can see this diagram also. Sir, if you are seeing this diagram, this point is called pole, right? And this line is called what? Tell me. Principal axis. This might be the focus, and here we are having the center of curvature. If I take an object here, okay, if I take an object here, AB, I will take two rays. One is parallel. When I took a parallel ray, it should go, supposed to go through the focus. Yes or no? But actually, it will bend, it deflect in this manner. Clear that thing now? It will deflect in this manner. But if I extend it backwards, it's supposed to go in this way towards the through the focus. It will go. Now what I am doing, another one. Which one you want me to take another condition? Sir, you can take any condition. So for example, this is C here, right? Try to draw a dotted line. Dotted line I drawn, right? You send the incident ray in that direction. That means you are sending through the center of curvature, but it will not go. What will happen? It will bounce back. It will bounce back after striking. But when you extend it backward, these two rays are meeting at this location, right? This is going to be your image. This is going to be your image. Understand? So all the time the image will be formed on the right side, right side of the pole. So that's why V is always positive. Keep that in mind. V is always positive for whom? For convex mirror only, not for the concave mirror. Yes, tell me.
So, image form will be always point size, so in convex.
Who said? Only when the object is at infinity, at that time only image formed is point size. But now what happened to the size? Diminished. This is also true. The image formed is diminished all the time. It's not the point size all the time. Clear that thing now? Diminished. Whatever you do, you will get a lesser. Understood that thing now? Sir, we understood what is U, what is V, and what is F. So we will see the special, the cases of concave mirror and convex mirror. We have to define U positive or U negative, M positive or M negative. Sir, what is M, sir? You are telling M, M, M. Sir, M is called magnification.
What we concave.
It may be positive, it may be negative. Both cases are there. That's why I didn't specify that. Okay. But for convex mirror, V is always positive. Okay. Now M means magnification. M means what? Magnification. So what is the formula for M we are having is one original formula is height of the image divided by height of the object. This is what original formula. Originally magnification means it. How much is the image height you are getting for a given height of the object. For example, here what happened? This is the height of the object. Here, this is the height of the image. Who is big? Object is bigger, image is bigger.
Object.
So our image got diminished, right? That's what. Oh, height of the image you have to write and height of the object you have to write. Obviously, it is going to be a diminished in that case. Clear that thing now? So m is equal to what? Tell me. Height of the image by height of the object. Is that clear for all? So there is another formula. M is equal to which is relating
V by U.
u and v. What is that? Minus v by u. Is that clear that whenever you want, you can equate whatever you wish in this and you can find the unknown. Understand? You can find the unknown of that. Let's see the next one. I said we'll see. Actually, here there are some characteristics of the image or nature of the image they used to tell. Means you need to talk about whether the image is first of all real or virtual. We have to tell first. What we have to tell? Is it real or virtual? We have to tell. Okay. Next thing is we have to tell erect or inverted. We have to tell. The third one is we have to tell is enlarged or diminished. We have to tell. Clear that thing now? Enlarged or diminished, we will tell. Sir, here we are having the persons who will define these all. V is there, right? We will talk about real or virtual. M will talk about erect or inverted. Then who will talk about enlarged or diminished? That is also M only. That is also M only. Clear that thing now? Let's see now. Sir, if V, remember, if V is positive, if V is positive, it is going to be a virtual image all the time. If V is positive, which image it is? Virtual image. Fix a stamp, you put it. If V is negative, it is a real image. So, in convex mirror, always which image will be formed?
Virtual.
Virtual image will be formed. Clear that thing now? And next, if M we are having, right? If M is positive, if M is positive, M is positive, which is nothing but erect image. If M is positive, which image it is? Erect image. Understand? If M is positive, it is erect image. If M is negative, we are going to get inverted image. If M is negative, we are going to get inverted image. Clear that thing now? Okay, sir. Now, to get enlarged or diminished, again M only, but magnitude of M. What do you mean by that, sir? Suppose M I gave it as like minus 2.5. M I gave it as like minus 2.5. Here, whatever the sign is there in front of that number, that is responsible for erect or inverted case. Okay, the number is there, right? This 2.5. That is responsible for enlarged or diminished case. Are you getting that thing now? That's why I will not tell it as like M. I will tell it as magnitude of M. What is that? Magnitude of M. Magnitude of M means don't consider the sign. Okay, don't consider the sign. Even though it is negative, you see it as a positive. Clear that thing. Only the value consider. Don't consider the sign. If I see the only value, is it how much it is?
Negative.
2.5. Is it how much it is?
2.5.
2.5. If that magnitude, I will indicate like this, magnitude of the M is greater than 1, it indicates enlarged
image.
image. Enlarged image. If magnitude of m is less than 1, it indicates diminished
Image.
image. Is that clear? So when enlarged, when diminished, we all well knows. Clear that thing now? Yes or no? Now I will go to the table and on that we will indicate V how it will be, U how it will be, M how it will be for that specific cases. Sir, what do you mean by specific cases? Yes, sir. We are having specific cases. For example, if object is placed here, what will happen? If object is placed here, what will happen? Like that, we are having so many specific cases, right? Yes or no? About that I am talking. For example, if you see this one, if you see this one, understand here, you have to tell why, because they will not ask. Sometimes they are asking convex mirror object is here or m value is this, u value is this. You are getting confused to take whether minus or plus or, like that confusion is coming. So to avoid that, we'll put everything in this table. Okay, whatever the cases, first case, second case, third case, u is always negative. Yes or no? U is always what?
Negative.
Negative. U is always negative wherever you place, always negative. Who is that guy? U negative. Is that clear? U is always negative. Okay. Now, position of image, which is nothing but V, right? Position of image is nothing but what?
V.
V. V can be positive, V can be
Negative.
negative, right? Now tell me in this case, focus. When the image is found at the focus, V will be positive. Clear that thing now? V will be positive. Between F and C, again positive. At C, again positive. Beyond C,
Negative.
beyond C, positive. Yes or no? Beyond C, positive.
Positive.
At infinity, positive. Understand? At infinity also,
Positive.
positive. Behind the mirror alone,
Negative.
negative. At infinity also positive. But behind the mirror only,
Negative.
negative. Is that clear? Behind the mirror means negative. Now come back. Size of the image. Size and we are telling that enlarged or diminished. We are telling, right. So observe that
Sir,
high diminished.
sir,
Yes.
sir, won't we be positive only for the last one? Rest all it would be
Sorry.
negative.
We said reverse. On the left side it should be negative negative. Sorry. Good one. Reverse we said. Okay. Good Akshay. Okay. See now. At F, negative, good. And negative, 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 negative.
Positive.
Only this case is positive. Good. Why? Because actually it is on the left, but I treated that as like positive. That's why I wrote it as like positive. That is wrong. Clear that point there. We know that all the things are on the left side only. So that's why it should be indicated as negative. Clear? Good. Now, diminished. Yes or no? Diminished or enlarged size will depend upon m, magnitude of m. I am correct or not? Magnitude of m. When you said diminished, it is
Lesser than
less than 1.
one.
Clear that thing, it is less than 1. Diminished means less than. Same size
Equal
means
to one.
equal to 1. Enlarged means
Greater than one.
greater than 1. Highly enlarged means greater than 1. And here also enlarged. Keep this in. Actually, they will ask condition. What are the possibilities to get a enlarged image? Enlarged image.
Image.
Enlarged and erect means only one case. Enlarged and inverted means there are two cases. Like that you have to clear that thing now. Okay, sir. Now observe. Here, inverted is there, right? When it is inverted, m will be positive or negative.
Negative. Negative.
So m is negative. Here m is
Negative.
negative. Here m is
Negative.
negative. Here m is negative. Here m is negative. Here m is.
Positive. Positive.
Oh, sir, it is very clear. One more point. Whenever m is negative, your v also coming as negative. Whenever m is positive, your v also coming positive. You can fix that. Based upon v, you can talk about whether it is inverted or erect also. If v is negative, inverted. Yes or no? If v is negative, inverted. If m is negative, inverted, and at the same time you can tell that it is a real image. It is a real image. That means it will form on the left side of the mirror. Is that clear, that point? If m is positive, erect image. Understand, m is positive, it is going to be a erect image. Where the image is going to form? On the right side, which is nothing but a virtual. Clear that thing now? We can write one point, right? What is the point we can write? Based upon the sign of the m and sign of the v, we are going to write the other nature. For example, if you said earlier, if m is positive, you said it is erect, right? Yes or no? At the same time, it is going to be virtual or real? Virtual. Means v is positive or negative? V should be positive. Clear that thing now? V should be positive. Understand? So if m only will write. If m is negative, we'll tell it as inverted is equal to what we will tell here? Real. Clear that thing now? We should be positive or negative? We should be negative. So these two lines, if you remember, you can write whatever the number he mentioned based upon that, which will be positive, which will be negative. Understand, which will be positive and which will be negative, we can write with the help of that. Is that clear for all? Any confusion is there in that? Sure. Understand? So till now, any doubt is there for anyone? No. Now next one, we are having the case of con. Tell me, convex.
Two cases.
So convex, there are only two cases. See, between infinity to pole, at any position you put, keep in mind, u will be negative, negative for both the cases. Here it is going to be v. V is positive, positive. It's now for whatever the thing, v will be positive. Diminished. So m should be less than 1, m should be less than 1, both the cases. And next, virtual and erect. Remember, see, when it is virtual, v should be what, tell me? V is positive. V should be what here? Positive. Erect means m should be positive. M should be positive. Keep in mind. Understand? M is positive. Erect. Inverted means M is negative. Clear that thing now? M is negative for inverted. Clear? So you can observe. Oh, when you write your table with U, V, M also, it will be very clear in problematic perspective. Understand? Problem also you can write very easily. You can remember. So everybody make the table along with u v m signs. Clear that thing now? Positive or negative, or and you have to submit it in a A4 sheet. You have to write and you have to show me by today end itself. That will not take much time. It will take only 10 minutes or 15 minutes. Sit and write and submit. Clear that thing now? I hope it is clear, right? Okay. let me go through the lens. Before going to the lens, we are having refractive index. Yes or no? Before going to the lens, we are having refractive index. Sir, what is the refractive index means? I'll take the problems all together. In refractive index, one strong statement is there. Just keep this word in mind. Snell's law. What is Snell's law? Tell me. Sin I by sin R is equal to constant. You are telling. That I will mix it with this at the end. Okay. Now see here. Here, one thing is there. N to 1. What is this? How will you read this one? Tell me. N to 1. Sir, what is the meaning of N to 1? The refractive index of medium 2 with respect to medium 1, or medium 1 with respect to medium 2. You have to be very clear. See here. Hmm?
Median 1 respect to median 2. It is.
No. N to 1 is medium 2 with respect to medium 1 only.
Dividing median 1 by 2.
That is speed. Don't see that. Okay, what is the meaning of N to 1? N to 1 meaning means here. See. The refractive index of medium 2 with respect to the medium 1 is nothing but n to 1. Clear that thing now? Or else you can see below. Refractive index of medium 1 with respect to medium 2 is n12. Understood that thing now? So please write this one here. What is n to 1? N to 1 meaning you understand first. Refractive index of medium 2. Refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. So what is the formula, sir? Then n to 1 is equal to v1 by v2, sir, formula. Understood? N to 1 is equal to V1 by V2. What is V1, sir? V1 is nothing but speed of light. What is that? Speed of light in medium 1. Clear that thing now? Divided by speed of light in medium 2. Sir, nowhere they will ask this. They will put some medium names. For example, water and glass I am taking. What I am taking? Water and glass I am taking. So, what is the refractive index of water with respect to glass? How will you indicate? N water with respect to glass. N water with respect to glass should be equal to velocity of light in glass divided by velocity of light in water. Clear that thing now? So when WG, G will be top, W will be at the bottom. What is that? Velocity or speed. Okay, speed only just don't write velocity. Speed of light in glass divided by speed of light in water. Is that clear that thing now? Yes or no? Sir, what about then N GW if I do? It will come reverse only, right? N GW will be V W by Vg. So when you want to relate these two, NWG is equal to 1 by N 1 by N GW. Is that clear that thing now? 1 by N GW. Understood that thing now? Is this clear? This based upon this, we will get some question. Okay, this is what I am telling. It is relative refractive index. Whatever I talked till now, these symbols are there, right? These all are relative
Fractals.
refractive index. Sir, because we are talking one medium with respect to the other medium. That's why I said it as like relative refractive index. So there is another thing called absolute refractive index. What is the another thing? Tell me. Absolute refractive
Index.
index. Here, what is the condition you write? One medium will fix it to air or vacuum. One medium will fix it to what? Air or vacuum. Oh, earlier you were telling water with glass you combined and tell. I told like NWG. What do you mean by that? Water with respect to glass. Appadi, it's not like that. What we have to do? N water with respect to air, n glass with respect to air. When it is nwg, you said that formula is velocity of speed of light in glass divided by speed of light in water, you said. Then what it should be? Speed of light in air, that is nothing but c, I will indicate special, divided by speed of light in water, that is again vw only I will indicate. Here what it will be?
C by
Speed
D.
of light in air divided by speed of light in glass. Clear? Sir, you will not indicate like this. Simply I will write it as NW. Simply NW meaning is what you are doing with respect to the air or vacuum. So here I will write it as simply
NG.
NG. Okay, well?
So on its
Yes
with
or no?
respect to
Now what I am doing is like, let me divide these two. This one is there, right? I will divide these two. What it will become if I divide? Observe very carefully. Sir, when you divide, C cancel, G will rise to this. Correct? So then what it will become? VG by VW is equal to what you are having? NW by NG. Sir, but what is VG by VW means? NWG. So the strongest relation which is very helpful for refractive index case is this. NWG is equal to VG by VW. VG by VW. Vg by Vw is equal to Nw by Ng. They will tell refract. This is I said now absolute refractive index. Simply they will call refractive index. If they said simply just refractive index of water, meaning is absolute refractive index of water only. So this is what tell me refractive
index.
index of water. Correct? Then what is this? Tell me. Refractive index of
Glass.
glass. What is this? Tell me. Refractive index of
Glass.
water with respect to
Glass.
glass. How many times you will do mistake? Okay, water with respect to
Glass.
glass. Water with respect to glass. If you know this, automatically you can do for all. Understood that thing now? Automatically you can do for all. Clear? I said at the beginning, you remember this sin I by sin R is equal to a constant we said. Yes or no is equal to a constant we said, which is nothing but equal to, remember, sin I by sin R, which is equal to NW means NW, or N G means Ng means refractive index of the water. You can equate it to sin I by sin R. What is the meaning of this? You know, incident ray is coming from air and going into the water. Then we will use this condition sin I by sin R. Clear that thing now? Sin I by sin R. Understood that thing? So what about this? Incident ray is coming from air and it is going into the water. So then I will use this condition sin I by sin R. I hope you know what is I and what is R. Yes or no? One strong point you remember whenever the incident ray, actually in glass lab itself we can talk. This is air and this is glass. Optically, this is a rarer medium. Optically, it is denser medium. When incident ray is coming like this, we have to drop the normal first. We have to drop the normal first. It suppose if there is no glass, it's supposed to go this way, right? Yes or no? And drop the normal properly fully. Okay. Now, since there is a difference in medium, the incident ray will bend towards the normal. Instead of going this way, it will bend. That means it will go this manner. Yes or no? When it will happen? Rarer to denser. When you are traveling from rarer to denser, bend towards the normal. It will bend towards the normal. Is that clear? That thing now? Reverse if it is denser to rarer means away from the normal. So when it is rarer to denser, which is bigger? I is bigger or is big? Angle of incidence I is greater than the angle of refraction. When rarer to denser. Clear? Denser to rarer means which is big? Tell me. Angle I is less than the angle R. Keep that in. Understand? Is that clear that thing now? Understood? So this is what you need to know about refractive index. Sir, that's it. No, no, no. One more guy is there. Who is that? Means apparent depth. One single statement that is. Okay, what is that apparent depth? Means observe that the actual depth of any container or any swimming pool is from here to this. This is actual depth. H actual depth. H I will write, not the actual H actual depth. But this bottom point will appear somewhere here. This is called apparent depth. I will indicate apparent depth as HA, actual depth as D. I will write. Clear that thing? Actual depth as D. There is a relationship between these two. What is that? D divided by HA is equal to refractive index of water, because I am using water here. Clear that thing now? Sir, what does that mean? Actual depth divided by apparent depth is equal to NW, refractive index of water. Is that clear that thing now? So just simple this state, this formula alone you remember, and if anything he ask, you can do with this form. Understood that thing now? Any confusion is there in this? No confusion, right? Can we go to the lens? Yes. So let's go to the lens formula. Sir, what is the lens formula, sir? Very simple, as like a mirror. Lens formula is 1 by V. You remember there also I started with 1 by V. Here also I wanted to start with 1 by V. Minus, there I wrote plus. That's why 1 by V I will start all the time. 1 by V plus, if it is there, that is mirror formula. 1 by V minus, if it is there, that is lens formula, is equal to 1 by V. Again here, who is F? Focal length. Focal length. Correct, sir. This f can be positive or this can be negative. For which lens it is positive means convex lens it is positive. Concave lens it is negative. Actually, they asked one day one question in board itself. Focal length is positive for no, they given reverse. They given what they given is like what is common between concave lens and concave mirror. Both of them are having the focal length negative. That is what the. So you remember one word. If it is convex, whether it is a lens or whether it is mirror, F will be what? Tell me. Positive. Keep this in mind. Concave lens or mirror, F will be what? Tell me. Negative. Fix it. Yes, our hero U is always negative, whether it is mirror or whether it is lens. Whether it is mirror or it is lens. Here V alone is a different guy. We told in mirrors, what I told in mirror, talk about the mirror 1 second. In mirror, if V is positive, is it real or virtual? If V is positive, we said it is virtual. Correct? If V is negative, we said it is real. Keep this in mind for the mirror. Okay, but for in lens, if V is positive, it is the real image. Reverse. If V is negative, that is the virtual image. Is that clear this thing now? So V is positive means real image, V is negative means virtual image. Understood? Any confusion is there in that? Sure. V is positive, real image. V is negative, virtual image. Sir, as like a mirror, here also there is a magnification formula. M is equal to, I said, height of the image by height of the object. Always it is true. Height of the image by height of the object is true for everybody, universal one, like that. Height of the image how much, height of the object is how much, that differ, that ratio only magnification factor or magnification we will tell, which is equal to in terms of V and U. There V positive real, V negative virtual, like this is reverse, right? That's why that minus will disappear and you just write V by U. There we are having a minus, here we are not having a minus. Very, very, very important formula. M is equal to height of the image by height of the object is equal to V by V. Sorry, V by U, not the minus. Okay, V by U. There is no minus. Clear that thing now? Now here same as like earlier, M is positive can become, or M negative it can become. If M is positive, if M is positive, what it will be? If M is positive, sir, enlarged only, sir. Yes or no? If M is negative, what it will be? Diminished. If M is negative, it will be diminished. Clear that thing now? Understood? Any confusion is there? No confusion. I hope it is clear, right? Now, the next thing is, sir, M. Sir, M I will tell la. Idu I will tell la. This is what I will tell, that magnitude of M. This meaning is what? Magnitude of M, which is if it is greater than 1, we will tell it as like, sir, you are wrong, sir. Earlier you wrote wrong, sir. Why you didn't notice it that? It should be written erect and inverted. Okay. magnitude is greater than 1, it is enlarged. If magnitude is less than 1, it is diminished. Okay, you have to notice. Clear that thing now. M positive negative is same. Erect and inverted. M greater than enlarged and diminished. Is that clear? Now we'll go to the table and we'll mark there so that it will be helpful for us. Yes or no? UV. Sir, because at the end he will ask draw the corresponding ray diagram. Yes or no? They will ask like that, right? Draw the corresponding ray diagram. Or else he will give differently. Without giving UV directly, he will give this is the situation. Then you have to assume whether it is positive or negative. Okay? Okay, see now. Sir, UV is always negative, 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 negative. Correct, right? That thing now. Yes or no? Sir, what you are doing? How many times you are writing? There is only two cases. This is full negative. That's it. Okay, clear that thing. Now let's come here. Position of the image. We write at F2. Remember, F1 is on the left side. F2 is on the right side. So it should be positive. Yes, sir, sir, sir.
Sir, negative.
Don't listen. Correct only done. Don't indicate here, sir. Better to indicate here. Why? Because you said now real means what it is? Positive. Real means positive. Right on the top of this as V, on the top of this as M. So V is positive, V is positive, V is positive, 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 negative. M inverted, negative,
Negative.
negative, 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 positive. Sir, earlier, M, whatever the sign it is having in mirror, listen, M, whatever the sign it is having in mirror, same sign V also is having, right? But here reverse. But here reverse. If M is positive, V should be negative. V is positive, M should be negative. Is that clear? That thing? Then what about M value? It is highly diminished. So less than 1, less than 1, equal to 1, enlarged. So it should be greater than 1. Very, very enlarged, greater than 1. It is greater than 1. Clear that thing now? And you have to note down the positions also. You have to remember. These tables surely will give you 1 or 2 marks in board exam. Tables, only the tables. Understand? Is that clear? Any confusion is there in this? Fine. Can I move to the next table? Sir, here it is very simple, sir. Which lens it is? Tell me.
Convex. Concave. Concave.
Which lens it is?
Concave.
Concave lens. So here U is always negative, negative. Here F1 it is forming. F1 is on the left side, we said, right. So it is going to be here it's virtual. It just observes. It is going to be virtual means what we said?
Negative.
Negative, negative. Sir, when V is negative, M automatically
Positive.
positive. See this now easily you can remember the things. You understand? And it is diminished means less than 1, less than 1 is less than 1. Clear that thing now? Any confusion is there?
No, sir.
Now you are clear with this M positive, M negative. Okay. Suppose I will tell one question I will ask. If M is positive, M is what happened? Positive. Nature. We have to talk about the nature. Nature means what you have to tell? Real or inverted, erect, sir, real or virtual, very good. Virtual, erect or inverted or magnified or diminished, you have to talk. Clear? See, I said only M positive. What all are the things you can tell? M positive, you said. Okay. M positive is there in three cases. Huh? Which are the three cases you are talking, sir? Two only, right? But in the earlier lens, convex lens, there is one place where your M is positive. Yes or no? One place or many places M is positive. Sure. Pakka. Just check that once. M is positive in how many cases? How many places in last one? Sir, M is positive in only one. That's why I said a total three. Is that clear? So now talk about all three should happen. Sir, M positive. When M is positive, V is automatically negative. So M positive means erect image. V negative means virtual image. The only thing you have to talk enlarged or diminished. You have to talk what? Tell me. Enlarged or diminished. Clear that thing now? Enlarged or diminished, you just observe three cases. Okay. If you observe here, two cases are showing diminished. Two cases are showing diminished. What about here, this third case? It is showing enlarged. You based upon this statement, positive and enlarged, if we said M is positive and enlarged, if you say, you have to fix it to this case. Clear that thing now? M is positive and diminished to point size. Diminished to point size, if we say, you have to take this case. Just diminished, if we say, we have to take this case. Clear that thing now? Diminished to point size, if we say, you have to take this case. Diminished, if you say, you have to take this. Actually, this much deep level they will not go. Okay, what they are expecting from you people is, for your school perspective I am teaching this. Okay, in board perspective this level they will not go. They are very clear. Are you able to recognize what is U? Are you able to recognize what is V? Are you able to recognize what is F and what is the M formula? Are you able to recognize? By applying all these formulas, you will get the answer. After getting the answer, are you able to match it with the table? Are you getting that thing now? That's it. On the level only it will be there. That is the level. Is that clear? Let's see now the last point. What is the last point? Power of the lens. Yes or no? That is only right. Last one. Power of the lens. Sir, power of the lens has one formula. What is that power of the lens formula? P is equal to 1 by F. Power of the lens, P is equal to 1 by F. Keep in mind, F should be in meters if you want to write this. F should be in meter. No, sir, in question F is given in centimeter. Then, okay, P is equal to 100 by F. P is equal to 100 by F. Clear that thing now? What is the unit for P? It is diopter. What is the unit for P? Diopter. Diopter is nothing but meter inverse. Diopter is nothing but meter inverse. Clear that thing now? Sir, one more thing. P is positive 5. Means P is equal to 5 I give. Which type of lens and what is its focus focal length? Which type of lens? Sir, P positive means F also positive. F positive which lens? Convex lens. Correct? P positive meaning is what? P is equal to 1 by F. P is 5. 1 by F. F is equal to how much is that? 1 by 5. So suppose if I am writing in centimeters, in place of this one I will write it as 100. How much it will become? 20. So 20 centimeter or else 0.2 meter. Both are correct. If it is 1 by f, we will get it as like 0.2 meter or 20 centimeter. Like this, you have to get one more question. There is a chance you can. If P is negative, if P is
Negative.
negative, P is negative,
Peace.
which lens?
Concave. Concave.
F also negative, very good. So it should be a concave lens. Sir, while calculating, don't involve that negative. That negative or positive is telling that which type of lens it is. For example, I told focal length how much? P is equal to some 4. So minus 4. P is equal to minus 4. What you will write? Just take 4 is equal to 100 by F. Keep in mind you are going to get in centimeters. So F is equal to how much? 100 by 4. Is how much? 25 centimeter. And who is that lens? Concave lens. Understood that thing now? Any confusion is there? No confusion. Sure. Okay. Take one more thing is there. We'll finish that and I'll do the problems. Suppose combination of lens. There are some lenses. I'm combining them like this. One lens whose focal length is f1 and whose power is p1. I'm combining this with another focal length f1, f2 and power is p2. What is the resultant power?
F1
What
plus
is the resultant power? Resultant power is P1 plus P2. What is the resultant focal length? It's not F, it is 1 by F. Resultant focal length, reciprocal of the resultant focal length is equal to 1 by F1 plus 1 by F2. The third one point you remember, magnification. Resultant magnification is equal to, it will be producing one magnification m1, it will be producing another magnification m2, product of those two magnifications, product of those two magnifications. Is that clear? That thing now, product of those two magnifications. Understand? Based upon this also, they can ask the questions. Based upon this also, they can ask the questions. Understand? Fine. Now, okay. Now take one 10 minutes break. Okay, we'll start solving the problems. Clear?
Secondly, only later if you have questions, sir.
You also take 10 minutes break. We'll start exactly 11:25. We'll solve the problems.
Tomorrow's examination is
Not there.